Stop for a second and look at the ground beneath your feet. Is it a quiet suburban street, a flat basketball court, or maybe a peaceful stretch of farmland? You probably feel safe because there isn't a giant smoking mountain on the horizon, but that safety is an illusion. Yeah, sure. Yellowstone, Vesuvius, or Mount Fuji, those are the celebrities of the geological world. Giants that dominate the skyline and sometimes blow their tops. But what about a hidden threat? One that doesn't look like a volcano at all. It's invisible, it's silent, and thousands of these traps are scattered across the planet, lurking right under the foundations of our biggest cities. Scientists call them monogenetic volcanic fields. To the untrained eye, they don't look like volcanoes at all. They disguise themselves as innocent hills, flat plains, or just lovely lakes. For decades, they were mainly ignored because of their small size. But new data suggests these hidden systems are far more dangerous than previously thought. And unlike the big giants that give weeks of warning rumbles, these invisible volcanoes specialize in surprise attacks. Hold tight. To understand the danger, we have to look at the plumbing. A standard volcano acts like a simple chimney. There is a central magma chamber and a main pipe leading to the surface. Eruption after eruption, lava flows out the same vent, building a massive cone over thousands of years. Monogenetic fields break all these rules. They don't build mountains. They don't reuse the same pipe. Instead of a chimney, imagine a cracked windshield. Magma deep underground scans for any weakness in the crust over a massive area. It pushes up, cracks the surface, erupts once, usually violently, and then calms down forever. The next time magma rises, it won't use that old vent. It will find a new crack 5 miles away, or 10. This means you can't just monitor one specific mountain. The entire region is a danger zone. And because each volcano is a one-and-done event, the landscape is deceptive. You could drive past the site of a violent ancient explosion every day on your way to work and simply see a grassy knoll. The scary part is the speed. In these fields, magma can rocket from 30 miles down to the surface in less than 24 hours. It moves at a speed of up to 4 miles per hour. That sounds slow for a car, but for melting rocks, that is the speed of an elevator. This isn't just a theoretical problem for empty deserts. Take Auckland, New Zealand. It's a stunning modern city with beautiful harbors and over 1 million residents. But Auckland is built directly on top of a geological minefield. Sounds a bit crazy, right? Beneath rugby stadiums, parks, and busy intersections lies the Auckland Volcanic Field. Those scenic green hills scattered across the city aren't just landscaping. They're the remains of over 53 separate volcanic eruptions. Rangitoto Island, which sits just offshore, emerged from the ocean only 600 years ago. In geological time, that was 5 minutes ago. For years, this field was considered sleepy, but recently, scientists have started noticing subtle changes. The terrifying reality of a field like this isn't that a volcano we already know will erupt again. It's that a new one can pop up and go from zero to a disaster in the blink of an eye. A bubble of magma could rise silently beneath a factory, a highway interchange, or a residential neighborhood. There is no designated safe zone because the threat is spread across the entire city map. History gives us a brutal example of how fast this happens. In 1943, a farmer named Dionisio Pulido was plowing his cornfield in Mexico, on the outskirts of Mexico City. It was a normal Tuesday. Suddenly, the ground cracked open right in front of him. Smoke hissed out, smelling of rotten eggs. Within 24 hours, that small crack in a flat field had transformed into a raging volcano 160 feet tall. Within a week, it stood 500 feet high. This was the birth of Paricutin. It wiped out 2 entire towns, leaving only the stone steeple of a church poking out of the hardened lava, a haunting monument that still stands today. This geological nightmare started in a simple cornfield, and it wasn't an isolated incident. Look at the Harat Rahat field in Saudi Arabia. In 1256, a massive fissure opened up near the city of Medina. It spewed lava for 52 days, creating a river of fire 14 miles long. Today, that same volcanic field is still there, and modern Medina has expanded right on top of the ancient lava flows. Now apply that same story to a suburb of Los Angeles, a district in Tokyo, or a neighborhood in Europe. In a matter of days, an entire city can be buried under ash. The risk is global, ranging from over 1,800 vents in the American Southwest to the restless Eifel region in Germany and similar fields in China. Experts warn that the real risk here isn't size, but frequency and location. These volcanoes tend to be explosive. When magma rises rapidly and hits groundwater, which is common under cities and fertile farmland, it flashes into steam. This creates a phreatomagnetic explosion. Instead of a slow, oozing river of lava that people can walk away from, the ground acts like a shotgun blast. It sends a massive column of ash and rock shooting into the atmosphere. In our modern world, this is a recipe for chaos. We rely on delicate systems, air travel, GPS signals, just-in-time supply chains. You don't need a supervolcano to crash the global economy. A small eruption near a major logistics hub is enough. Remember the 2010 eruption in Iceland? That wasn't even a big explosion by historical standards. Yet, the ash cloud grounded over 100,000 flights, and 10 million passengers were stranded. Volcanic ash melts inside jet engines, while toxic dust poisons crops and contaminates water reservoirs with heavy metals. It creates a domino effect. One small eruption in the wrong place triggers a cascading failure of global infrastructure. And the most alarming part is that the signals are already there. Recent geological studies have shown an uptick in activity in these distributed fields. It isn't always violent earthquakes. Often, it's bradyseism, the slow rhythmic breathing of the ground. We mentioned the Eifel region of Germany, where GPS data shows the land is rising by about 0.04 inches per year. It sounds tiny, but for geologists, that is a proper red flag. Scientists are detecting slight swells in the Earth's crust and weird spikes in carbon dioxide emissions in places that should be quiet. Magma is moving, but because these systems are so spread out, monitoring them is a nightmare. We have sensors all over Yellowstone. We watch Vesuvius 24/7, but almost no one is watching a random patch of desert in Arizona or a forest floor in Germany. These invisible volcanoes are poorly studied. We lack the baseline data to know if a tremor is just a truck driving by or the start of a Perikutin-style event. This lack of data means that when an eruption starts, authorities might have almost zero warning. In a polygenetic volcano, the mountain swells for months. In a monogenetic field, magma can shoot from the deep mantle to the surface in hours. By the time the evacuation order is written, the lava could already be breaking through the pavement. It isn't that hard to imagine the logistical nightmare. A city not known for volcanoes suddenly receives an alert. A vent is forming downtown. It sounds impossible. People delay leaving. They grab their phones to film the smoke. Then, explosions start. The ash creates a blackout. Power grids fail as wet ash shorts out transformers. Roads gridlock instantly. This scenario isn't science fiction. It's exactly what hazard models predict for places like the Auckland volcanic field or parts of the Trans-Mexican volcanic belt. We are building denser and denser cities on top of geological landmines. This doesn't mean we need to start digging bunkers, but it does require a shift in perspective. We have spent so much time worrying about the celebrity volcanoes that we forgot about the quiet ones. The Earth is a living, shifting engine that doesn't care about property lines or city limits. Scientists are now pushing for better monitoring networks, using satellites to track even the tiniest ground deformation in these boring, flat fields. Because the only way to survive a surprise attack is to see it coming before the ground cracks open. Peace and quiet on the surface doesn't always mean peace and quiet underneath. The Earth has plenty of secrets left, and some of them are just waiting for the right moment to surface.
Deep inside our planet, there are two massive blobs of rock that have puzzled scientists for years. They sit deep inside, opposite each other. One lurks under the Pacific Ocean, the other under Africa. And they're so weird, they even make seismic waves slow down. Their actual name is large, low-velocity provinces, but they're just two enormous, mysterious blobs of rock, bigger than continents, stranger than anything else inside the Earth, and so dense they might be leftovers from another planet. Until recently, no one knew what they were, where they came from, or why they even exist. These mysterious blobs could hold the secret to Earth's deepest forces, powerful enough to shape earthquakes, drive volcanic eruptions, and even influence the evolution of life itself. And now, we might finally learn the truth about them. These geological monsters are hidden about 1,800 miles beneath the surface. Each one is 100 times taller than Mount Everest, so vast they defy explanation. Now, at first, scientists thought these were primordial remnants from Earth's early days. Maybe something giant smashed into Earth about 4.5 billion years ago, and this impact formed both the Moon and these blobs. Scientists believe it could have been a planet named Theia, a Mars-sized planet that existed somewhere around the asteroid belt and slammed into Earth back in the day. Others believe it could be something much more familiar, old chunks of Earth's crust. Perhaps they got pushed deep into the mantle by the movement of tectonic plates. And now, a new study shows that these blobs are massive piles of oceanic crust that have been sinking into the Earth for billions of years. They could have formed from the stuff that sinks into Earth when tectonic plates collide. Over 1 billion years, pieces of ocean crust could have been swallowed by the mantle. Eventually, they collected into 2 massive regions deep inside the planet. But even though both blobs form the same way, they aren't identical. There's this place called the Pacific Ring of Fire, a giant loop of volcanoes and earthquake zones around the Pacific Ocean. Well, the Pacific blob doesn't just stop growing and changing because it's constantly being fed fresh rock from that place. Tectonic plates crash into each other, and one plate sinks beneath another, pushing old ocean crust deep into the Earth. Since this keeps happening, the Pacific blob is heavier, denser, and more active than its twin under Africa. It's like a giant hot rock factory, constantly getting new material and reshaping itself over time. The African blob is much older and quieter than the one under the Pacific. It doesn't get fresh rock pushed into it as often. That's why, over time, it has blended more with the surrounding mantle. Since it's less dense, it behaves differently. It rises higher into the Earth's mantle, stretching 340 miles closer to the surface. And that might be why Africa has so many powerful volcanoes and rift valleys today. The biggest question is, how do they keep evolving? Scientists think that huge columns of hot rock, called mantle plumes, might be pushing up from deep inside the Earth, helping to drive the movement of tectonic plates in the Pacific. If they're right, then these giant underground blobs aren't just sitting there. They're almost alive in a way. They'd be constantly changing and shaping the surface of our planet. But why do they even matter? Because these weird underground structures may be shaping Earth's surface in ways we don't fully understand yet. You see, first, they might influence Earth's magnetic field. That's because they affect how heat moves through the mantle and core. They might also hold clues about the history of plate tectonics. Studying them could help us figure out when subduction began on Earth, whether it was over 4 billion years ago or much more recently. These guys might also be secret puppet masters behind volcanic activity. There's a theory that blazing hot rock from deep inside the Earth, the same kind that creates volcanic hotspots, might be rising straight from the giant blobs in the mantle. Some of the biggest volcanoes on Earth, including those in Hawaii, Iceland, and Yellowstone, sit directly above the suspected rising plumes from these blobs. If these blobs are fueling these volcanoes, then they could be responsible for shaping Earth's continents, climate, and even mass extinctions throughout history. And well, that's horrifying. That would mean that these giant structures might burst through Earth's crust one day, unleashing catastrophic supervolcanic eruptions, and these eruptions would last for millions of years. Beneath the Earth's surface also lies monsters unlike anything else on this planet – supervolcanoes. They're so massive, so destructive, and so rare that no human has ever witnessed one erupt. A regular volcanic eruption can be terrifying. Lava spewing into the sky, ash choking the air, entire cities buried under fire and stone. But a supervolcano? Well, that's something else entirely. A supervolcano isn't just big, it's a category of its own. Their eruptions rip apart the Earth itself, creating massive craters called calderas. Some of them are over 30 miles wide. A regular volcanic eruption might spew out a few cubic miles of lava and ash. A supervolcano unleashes more than 240 cubic miles of material. That's enough to bury an entire continent in ash. An eruption like this would be newsworthy, to say the least. First, a wall of fire would blow up into the sky. Ash would block out the sun for years, dropping global temperatures. Entire countries could be buried under meters of ash, making farming impossible. Famine, extreme cold, and toxic air could wipe out entire civilizations. It wouldn't just be a local disaster, it would be global. In fact, two of the worst mass extinctions in Earth's history, where almost all life was wiped out, might have been caused by supervolcanoes, not asteroids. The biggest and most horrifying one was at the end of the Permian period. Literally, about 90% of all marine species and 70% of land species went poof. Scientists have counted about 20 supervolcanoes on Earth today. The most famous ones are Yellowstone in the US, Toba in Indonesia, and Topau in New Zealand. Now, the last time Yellowstone erupted was roughly 2 million years ago. It released almost 590 cubic miles of material, enough to bury a city like New York. That was just one of 3 Yellowstone supereruptions. The most recent supervolcano to erupt was Topau in New Zealand. This happened about 26,500 years ago. But supervolcanoes don't just destroy, they reshape the entire planet. About 74,000 years ago, the Toba supervolcano erupted in Indonesia. Some scientists believe it triggered a volcanic winter that lasted an entire decade. There are also theories that suggest that this eruption nearly wiped out early humans. It reduced their numbers to just a few thousand survivors, although that's just speculation. Either way, we know for sure that supervolcano eruptions have changed the course of history. So, how do we prepare for them if this could happen at any moment? Well, scientists monitor volcanoes constantly, looking for warning signs. It could be stuff like rising magma, ground swelling, earthquakes beneath a volcano, changes in gas emissions, and so on. The problem is that while we can predict short-term eruptions, the long-term ones are still a mystery. Yellowstone last erupted 630,000 years ago. It's literally overdue for another eruption already. But volcanoes don't work like clocks. Just because one erupted in the past doesn't mean it will definitely go wild again, and the time between eruptions could be random. Scientists think Yellowstone could erupt again, but it might be just a small lava flow instead of a super eruption. Are we ready for a super eruption if it happens? Probably not. Scientists say we're more prepared for an asteroid strike than a supervolcano eruption. When Hunga Tonga Hunga Ha'apai erupted in 2022, it cut off communications, caused tsunamis, and filled the sky with ash. And that was only a magnitude 5 eruption. A supervolcano would be orders of magnitude worse. So, good luck sleeping at night knowing these guys will erupt again. Maybe tomorrow, maybe in 100,000 years. Nah, don't lose sleep over it.
We know more about space than we do about the ocean. We know more about the ocean than we do about the Earth's core. But how do we study something that lies more than 1,000 miles beneath our feet? Oddly enough, you need to fly into space. Thanks to satellites orbiting the planet, scientists have discovered something strange at the very heart of the planet. News about mysterious signals from space barely surprises anyone. But how about this? We detected strange signals coming from deep beneath our own home. Before we go into those signals, we need to understand why it's so important to study what's inside the planet. How does the core affect us? Our lives depend on it in several crucial ways. First, the core plays a fundamental role in gravity. We don't drift off into space because a massive spherical mass of molten metal locks us to the surface. Second, it powers Earth's magnetic field. Dangerous cosmic radiation and solar wind that could scorch everything are blocked thanks to the planet's magnetic field. And third, The inner processes of the Earth influence earthquakes and volcanic eruptions. Any disturbance inside the core and mantle can change life on the planet. And recently, scientists recorded something unusual coming from down there. At the beginning of this century, the United States and Germany launched a mission called GRACE, the Gravity Recovery and Climate Experiment. At first, this project used 2 satellites to track how water moved around the planet and how glaciers were melting. But the satellites could also measure Earth's gravitational field. If gravity was slightly stronger or weaker in some region, one of the satellites would be pulled toward that spot, and the other would measure the change in distance. In very simple terms, the heavier something is, the stronger its gravitational pull. In certain parts of the planet, gravity can be slightly higher because of large geological shifts, ocean currents, or melting ice. But between 2006 and 2008, the GRACE satellites detected a strange change in gravity along the coast of Africa. Melting ice, water movement, and other natural phenomena couldn't explain the anomaly. No one knew what it was at the time, but years later, scientists suggested that the nature of this signal was coming from the Earth's core. Researchers noticed that some minerals, like perovskite, can undergo a phase transition when exposed to enormous pressure and extreme heat. And there are many perovskites lying in the upper layers of the mantle. When the internal structure of this mineral reshapes, it becomes denser and shifts the surrounding rocks. Deep underground, this harder, solid part moves the softer molten rock. These movements reach the molten outer core and slightly deform it. This deformation inside the core alters the flow of molten iron, and this deep current of liquid metal directly affects Earth's magnetic field. That's why satellites recorded those fluctuations. So how does all of this affect us? We launch satellites, we use compasses, we rely on GPS. All of this works only because gravity and the magnetic field are stable, and both depend on the core. That's why it's so important to study the Earth's heart. And to do that, we don't need to dig thousands of miles. Movements on the surface can reveal what is happening inside. Studying vibrations in the crust, recording gravitational shifts, calculating, modeling, and forming hypotheses. It all sounds a little boring. Is there another way to figure out what's happening down there? We sent Voyagers into space, and some of them have already left the solar system. We descend into the depths of the Mariana Trench inside bathyskiffs. So what's the problem with drilling a shaft deep into the Earth's crust? Humanity actually has some experience with this. In the 1970s, Soviet geologists began drilling the Kola super deep borehole. It became and remains the deepest artificial borehole ever created. Its depth reaches 7.6 miles, deeper than the Mariana Trench and higher than Mount Everest. More than 50 years have passed, and humanity has not gone deeper than 7.6 miles. And do you know where the Earth's core begins? At about 1,800 miles down. That's almost 7 times farther than the distance to the International Space Station. To reach the core, we would need to drill a hole 230 times deeper than the Kola Super Deep. But that project was shut down in 1992, and the borehole was closed in 2005. What stopped us from digging deeper? First, the density of the rock. In the early stages, the drill easily cut through granite, but around 4.3 miles down, the rock became much harder. The drill broke several times. Workers had to change the drilling direction to pass through softer layers. Eventually, the borehole's shape looked like a string of lights hanging on a Christmas tree. Another problem was heat. The deeper the engineers went, the hotter it became. Scientists expected that past a depth of 10,000 feet, the temperature would be around 212 degrees Fahrenheit. In reality, the harder they worked, the worse it got. Eventually, it reached 356 degrees Fahrenheit. The hottest place on Earth is the Sonoran Desert along the Mexican-US border. Temperatures there can reach 177 degrees Fahrenheit. That's twice as cool as inside that terrifying borehole. And the challenges did not stop there. At a depth of about 14,800 feet, the rock became porous. The extreme heat gave it a strange plasticity. Instead of solid stone, the drill had to cut through something more like hot, softened material that was almost impossible to drill. On top of that, the stability of the shaft became a danger. At such depths, the walls could collapse at any moment. To drill deeper, humanity would need completely new technology, a drill capable of working at 500 degrees Fahrenheit. That is the temperature scientists expect in the upper mantle, located just beneath the crust. And to reach it, we would need to drill 25 miles down, almost 3 times deeper than the Kola Super Deep. There are many rumors about what the engineers supposedly discovered in that hole. The most popular claim is that they heard the screams of thousands of people who were stuck in the fiery underworld. Other fake stories claim that the workers went insane after seeing something horrific at the bottom, and that's why the project was stopped. But if we ignore these myths, what did scientists actually find? They learned that the existing temperature model of Earth's interior was wrong. It was far hotter down there than expected. Geologists thought they would find the so-called Conrad discontinuity, a transition from granite to basalt. They found no such boundary. The real discovery was a liquid at incredible depths. Scientists found cracks filled with briny water. This changed our understanding of the crust. People used to believe it was completely solid, but now it appears full of fractures and channels through which water can move. Where did it come from? Geologists think the fluid was squeezed out of the rocks by enormous pressure, as water is wrung out of a sponge. But the most astonishing discovery was life. At about 4.5 miles down, engineers found ancient fossils of single-celled marine organisms. They were nearly 2 billion years old, and they had survived at such extreme heat and pressure. Let's imagine that one day we actually reach the mantle. What would that give us? What would we expect to see? We would finally understand how Earth formed billions of years ago, how the core, mantle, and crust developed, and how plate tectonics works. We'd know how the plates push and pull against each other. We'd gain a deeper understanding of earthquakes. Researchers also hope to find extremophiles. These are primitive organisms that can withstand extreme heat and pressure. If we discover life near the mantle or even within it, scientists will study it closely and try to understand how it manages to survive under such brutal conditions. If we learn what keeps life alive in the most hostile environment beneath our feet, we might learn how to protect life in other extreme places, from the depths of the ocean to distant planets. Studying the heart of our planet could reveal technologies we can barely imagine today. Our future might depend on the mysteries hidden beneath our own world.
Oh look, there's a giant blob heading straight for New York City. Oh wait, hold on. You'll actually have to look down, not up, because this blob is a mass of hot rock moving beneath the Earth's surface. And when it finally reaches the Big Apple, some say it could tear the continent in two. But Yankees fans, and even you Mets fans, don't worry, this journey is going to take about 15 million years or so. You see, a long time ago, people noticed something curious. When they looked at world maps, they thought, don't the continents look like puzzle pieces that could fit together? That couldn't just be a coincidence, right? Then, in the year 1912, a German meteorologist named Alfred Wegener came up with a revolutionary idea, something we now know as the theory of continental drift. Wegener said the continents are always on the move, and those huge chunks of land we see today were all once connected, forming one giant supercontinent called Pangea. That idea suddenly explained a lot of mysteries, like why fossils from the same species turn up in different corners of the world, even though entire oceans lie between them, or why coastlines of continents match up so neatly, just like South America and Africa. Wegener also explained that mountains form when a drifting continent runs into another one, crumpling the land and pushing it upward. That is exactly how the Himalayas came to be. The Indian plate collided with the Eurasian plate, and the land rose into the massive mountain range we see today. Now these days, everybody learns about Wegener's idea in school and takes it as fact. But back then, many people thought he was completely out of his mind. I mean, whole continents moving around? What on earth could push them? That's why it took scientists more than 50 years to finally go, "Oh, I see. It's the Earth's mantle." Yep, slow-moving currents of hot rock deep in the Earth's mantle push the tectonic plates around, and that means the continents move too. Picture super tough puzzle pieces floating on top of boiling oatmeal. That's a picture. Yep, they drift, and sooner or later they crash into each other. This is what happens on Earth's surface. And that's how we finally agreed that Wegener was right. But what if I told you that might not always be the case? Some experts agree that the Supercontinent Pangea started breaking apart about 200 million years ago. And that's how we ended up with the world map we know today. But a recent study is challenging part of that idea. And it all comes down to a giant mass of hot rock, something scientists call the Northern Appalachian Anomaly, or just NAA. Yep, what we casually call a blob, the experts call an anomaly, and that is simply because it is hotter than the rock around it. So this anomaly sits about 124 miles beneath the mountains of New England and stretches up to 249 miles wide. It lies in the asthenosphere, the semi-molten layer of Earth's upper mantle. But here's the strange part. It should not even be there. I mean, rock formations like this normally don't exist in that part of Earth's interior. For years, scientists thought the anomaly was left over from when the North American continent broke apart from Northwest Africa about 180 million years ago. This new study says that might not be the case. It suggests the blob is actually linked to the process that split Greenland from North America only about 80 million years ago. The idea then is that this blob is a leftover from when the landmass broke apart, a piece that never quite settled down. This is one stubborn blob we're talking about because it is still on the move, super slowly. But still, it moves only about 12 miles in a million years. Over time, it's already traveled more than 1,100 miles from where it first appeared. And now, New Yorkers, watch out! This blob of scorching hot rock is heading your way. Okay, I know, I'm being a little dramatic. The truth is, we really don't have to worry. First, scientists say it won't even get near the city for at least 15 million years. And second, even though we call it a blob, it is not something gelatinous. It is not oozing. And it is definitely not going to push its way up through the Earth's crust and invade the New York subway, or anything like that. That is just not going to happen. What the anomaly will look like, or what it might do to the continent in the future, is still a mystery for geologists. But they are pretty confident it will not have any real impact on human infrastructure or on our daily lives. It is not like lava that's suddenly going to burst through the floor of your house. That's because, at the end of the day, the blob is just rock. Like any rock you see on the street, only super high, enormous, and buried deep inside the Earth. To explain why this rock is sitting in such a weird spot, scientists came up with what they call the mantle wave theory. So think of it kind of like a lava lamp. After continents break apart, hot, heavy rock can detach from the bottom of the tectonic plates in blobs. These blobs, or pieces of rock, move around under the crust and create waves. When that hot material slips under a continent, it works like the flame under a hot air balloon. It gives the land a little lift. Then, when continents stretch and split, space opens up underneath and semi-molten rock quickly fills in. Eventually, it cools down, gets heavier, and sinks. Meanwhile, hotter mantle material rises up and creates a warm patch called a thermal anomaly. This sudden motion shakes up the base of the continent. Imagine a row of dominoes. One piece falls and the rest follows. Blobs of rock start dripping downward one after another, and over time, they slowly move inland. Scientists think these rock currents keep flowing, rippling under the surface for millions of years. Now, knowing all this matters because the anomaly might have played a role in shaping the land above it. For example, It may have lifted up some ancient mountains over the past few million years. That helps to explain a big mystery of the region: why the Appalachians are still standing. I mean, why haven't they worn down as much as you would expect after all this time? Well, think about it. The Appalachians are ancient. This mountain range in North America started forming hundreds of millions of years ago, long before the dinosaurs. With all that time, rain, wind, and erosion should have worn them down to almost nothing by now. Honestly, some geologists expected them to be rolling hills at best. But nope, they're still mountains, pretty ones too, and much bigger than they should be. And here's where the blob comes in. See, when a giant pocket of superhot rock sits under a mountain range, it can actually give the crust a little lift. It's kind of like putting a balloon under a blanket. The blanket rises up. The heat makes the Earth's crust lighter. So even while wind and rain are wearing the mountains down from above, the Earth is gently pushing them back up from below. There is another positive takeaway from this study. These new insights can help scientists better understand other strange geological features around the world. In fact, the researchers believe they may have already found a twin to this blob, sitting under north-central Greenland and also tied to the Labrador Sea. So, what can we conclude from all this? Well, tectonic plate movement is still the reasons continents break apart. But the process goes much deeper than we thought. The effects of ancient rifting can still play out millions of years after the surface split, just like what happened in Greenland. Although it's still really hard to predict what this anomaly will look like in the future, we know one thing for sure right now: there is nothing to fear, and I'm betting that most of us won't be around for that.
A long time ago, a huge meteorite smashed into the Earth with a horrible destructive power. It was several times bigger than the one that wiped out the dinosaurs 65 million years ago. Luckily, there were no lives it could have taken, or else it would have been a real catastrophe. Now, scientists think it did leave behind a huge footprint: the massive Antarctica impact crater that is bigger than the entire state of New York. The location also has a gravitational Wilkes Land anomaly going on. At first, scientists noticed something weird here when they measured Earth's gravity in that region: a strange gravity hole, or a negative gravity anomaly. Later, with better technology, they found something even weirder. There was a positive gravity anomaly inside that gravity hole, a spot with stronger gravity. This kind of structure, called a mascon, short for mass concentration, often shows up in places where giant space rocks or meteorites have slammed into the planet. When a meteor hits hard enough, it punches through the Earth's crust and shakes the mantle below. It can spring back up and leave behind a super dense plug of material, which causes stronger gravity right in the center of the crater. It's something like a frosty donut, with ice filling the gap and a dense center rising up from underneath. In 2018, scientists used advanced scanning techniques to study and map the Wilkes Land meteorite impact in more detail than ever before. They saw that it wasn't a perfect circle, but more of a U-shape, and the northern part looked like something had broken it apart. It possibly happened when Australia split away from Antarctica about 35 million years ago. Some scientists even think you can still see parts of the crater in southern Australia today. This clue also supports the idea that the giant crater under Antarctica formed before the continents broke apart. There have been different ideas about what created this strange formation. Some said it might be a volcano or an eroded valley, or even a sedimentary basin. That is a place where sediments build up over millions of years. But many scientists now believe the most likely explanation is a massive meteor impact. It was possibly one of the biggest to ever hit Earth. A 2015 study even estimated the age of the crater as its size matches the kind of space rocks that smashed into Earth between 4.1 and 3.8 billion years ago. The Wilkes Land meteorite impact was so powerful because the meteor that caused it could have been up to 30 miles wide. That's 4 to 5 times wider than the Chicxulub meteor that wiped out the dinosaurs 66 million years ago. Even that meteor was enough to cause massive destruction with wildfires, acid rain, tsunamis, and a climate crash that wiped out about 75% of all existing life. So it was lucky in a way that the meteorite that gave us the giant crater under Antarctica visited at a time when there were only microbes and no plants or animals on Earth. It didn't cause mass extinction or leave behind charcoal from ancient fires, but it may have changed the entire planet. Still, scientists haven't put the Wilkes Land anomaly mystery in the solved files because the crater is buried deep under Antarctica's thick ice sheet. It's hard to study up close. Scientists say we can't rule out the other ideas just yet, but if the meteor theory is right, then the Wilkes Land crater could be the largest known impact crater on Earth. So far, this title belongs to another contestant, the Vredefort crater in South Africa. Right now, the crater is around 99 miles wide, which is huge. But it's not as wide as the Chicxulub crater in Mexico, which is about 112 miles wide. But the Vredefort crater used to be way bigger, around 155 to 174 miles wide, before time and erosion wore it down. That means even though the Chicxulub impact was striking, the Vredefort impact was likely even more powerful, the biggest one we know of that hit Earth. According to the latest study, that asteroid was 12.4 to 15.5 miles wide and might have hit Earth at a speed of 45,000 to 56,000 miles per hour. It's important for science because knowing the real size of this impact helps us build better models to understand Earth's geology and how giant impacts shape planets, even beyond Earth. Measuring ancient craters is really tricky. Over 2 billion years, erosion wears away the edges and newer rocks form over the crater. That's what happened to Vredefort. Now, only small bits of the original crater rim are visible, and the rest is hidden under newer rock. To figure out its true size, scientists studied minerals like quartz and zircon found around the crater. These minerals still have fractures and shock patterns that show us how powerful the blast was. Wilkes Land anomaly isn't the only case on our planet where gravity is acting weirdly. For over 40 years, scientists were trying to solve a strange mystery in Canada. Parts of the country, especially around Hudson Bay, seem to have less gravity than the rest of the world. That means if you stepped on a scale there, you'd weigh just a tiny bit less than usual. Researchers first discovered this weird difference in the 1960s when they were mapping Earth's gravity. Gravity is linked to mass. The more mass there is, the stronger the gravity. And since Earth isn't shaped perfectly like a ball but is slightly squashed at the poles and bulges at the equator, it makes sense that its mass isn't spread out evenly. So, the first out of the two main theories to explain the Hudson Bay mystery has to do with magma. Yes, that super hot, gooey rock deep under our planet's surface. Magma constantly churns like boiling soup in a process called convection. As this magma moves, it can drag parts of Earth's crust down with it. That makes the area lighter, which lowers the gravity. The second area has to do with the Laurentide ice sheet, a massive glacier that covered much of Canada during the last ice age. This ice was up to 2.3 miles thick in some parts of Hudson's Bay. That's like stacking 10 Empire State Buildings on top of each other. Because it was so heavy, the ice pressed the land down like a thumb on a sponge. Even though the ice melted away about 10,000 years ago, the land underneath is still slowly bouncing back, kind of like a memory foam mattress after you get up. This slow rise is called glacial rebound, and it's happening at less than half an inch per year. Until the land fully bounces back, which could take 5,000 more years, it will continue to have less mass, and that means less gravity. Both of these theories are right. To figure this out, scientists used super advanced satellites, which floated around 300 miles above Earth for several years. These satellites flew in pairs and detected how far apart they were pulled as they passed over areas like Hudson Bay to measure tiny changes in gravity. When the front satellite passed over a low-gravity area, it drifted just slightly, and that change was recorded. Thanks to this research, scientists created detailed maps showing what Hudson Bay looked like during the last ice age. They discovered two huge bulges on the west and east sides, where the ice was thickest. And those spots have the weakest gravity today. The effects of this are still visible, and while sea levels are rising in most parts of the world, the land around Hudson Bay is rising so fast that sea levels there are actually dropping. Solving mysteries like this or the Antarctica impact crater anomaly gives scientists amazing insights into the past of our planet. And by understanding how past changes in temperature and geology affected Earth, scientists can predict how today's human activity can impact our future. There's an old volcano in Bolivia called Uturuncu. It hasn't erupted in about 250,000 years, so you may think that's the end of its story. But recently, it has started to act a little strangely. At the moment, it resembles a zombie that's waking up from a long nap. Uh-oh, is that kind of apocalypse nearing? Uturuncu is a huge mountain in the Andes that's almost 20,000 feet tall. It's called a stratovolcano, which means it's big, steep, and cone-shaped. These kinds of volcanoes are made from layers of lava, ash, and rocks. They can have terrifying, powerful, explosive eruptions because their lava is thick and traps gas inside. Think of it like a shaken-up soda that's ready to burst. Famous ones like Mount Vesuvius are just like Uturuncu. And do you remember about the tragic fate of Pompeii, completely destroyed during the eruption of Mount Vesuvius? Does something similar await Bolivia? Even though Uturuncu has been quiet for a long time, scientists have noticed that it's been letting out gas, rumbling with small earthquakes, and even making the ground around it bulge, kind of like it's stretching. So, people started wondering if it was getting ready to erupt again. Scientists decided to take a closer look at this situation and found out that liquid and gas moving around under the volcano is causing all this activity. It doesn't mean the volcano is definitely going to erupt, but it helps explain why it still seems alive. Let's dive into details. Since the 1990s, scientists have been using satellites and GPS to keep an eye on the ground around the Uturuncu volcano. At one point, they noticed something weird. The ground was rising in the middle and sinking around the edges, kind of like a sombrero hat. The middle part has been slowly going up for at least 50 years by about 0.4 inches a year. It doesn't sound like a lot, but hold on. This strange shape, along with lots of tiny earthquakes and gas like carbon dioxide coming out of the volcano, made scientists think that there might be a giant blob of magma growing under the mountain. If that were true, it could mean only one scary thing. The volcano could be getting ready to erupt. Uturuncu sits on top of a huge underground pool of magma called the Altiplano Puna magma body. This pool is really big and really deep, stretching under parts of Bolivia, Chile, and Argentina. Scientists thought that magma from the APMB might be rising and collecting near the surface, which could lead to an eruption. But now, after studying more than 1,700 earthquakes and checking the rocks around the volcano, scientists have a new idea. Apparently, it's not magma rising up. Instead, hot fluids and gases are traveling up from the APMB through a narrow path shaped like a chimney. These gases, like steam and CO2, can get trapped under the top of the volcano, while salty water, brine, spreads out sideways into tiny cracks in the rocks. This moving gas and water can make the ground rise and fall and cause small quakes, without any magma getting close to the surface. So the good news is, Uturuncu probably isn't about to erupt. If it did happen, it would cause serious damage to nearby communities and even pose a threat to human lives. Lava flows could reach towns tens of miles away from the volcano, and volcanic ash could even spread across Bolivia, Argentina, and Chile. Luckily, even though the volcano is still alive and rumbling, it's not as dangerous as scientists once thought. This discovery might help scientists figure out if other volcanoes around the world are getting ready to erupt. Now, let's visit Alaska, where according to researchers, Mount Spur might erupt soon. It's letting out strange amounts of volcanic gases from the top and side vent, the very vent that last erupted in 1992. If it erupts again, it could cause problems for airplanes flying nearby and might send ash falling from the sky. The good news is that nobody lives close to it, so people are safe for now. But even though Mount Spur isn't super dangerous, there are other volcanoes around the world that could be really destructive. One of those is Campi Flegrei, a giant volcano system near the city of Naples. Instead of one big mountain, it has 24 craters spread across the area. It last erupted in 1538, but its biggest eruption happened about 40,000 years ago. That explosion covered the whole Mediterranean region in ash and made temperatures drop by up to 16.2 degrees Fahrenheit in Eastern Europe, which led to a very cold volcanic winter. If Campi Flegrei erupted again today, it could be very dangerous. It might cover Naples and nearby places in ash, causing earthquakes and landslides, and create air pollution and acid rain. Scientists are keeping an eye on it, especially after a 4.4 magnitude earthquake shook the area in March 2025. But the good news is there's no sign that magma is rising to the surface right now, which means an eruption isn't expected soon. Still, since Italy has a lot of volcanic activity, experts continue to watch it carefully. Mount Vesuvius is also in Italy and is one of the most famous volcanoes in the world. It's known for its huge eruption in 79 CE that buried the Roman cities of Pompeii and Herculaneum. The last time the volcano erupted was in 1944. Today, Vesuvius is even more dangerous because over 3 million people live near it. Around 700,000 people are living illegally right on its slopes, which puts them even more at risk. If the volcano erupts again, it could send rocks and ash flying through the air at nearly 100 miles per hour and cause major destruction, possibly even wiping out Naples. And still, scientists believe a big eruption from Vesuvius probably won't happen for a few hundred more years. But since it's still an active volcano, researchers continue to monitor it. Cumbre Vieja is a volcano on the island of La Palma, which is part of the Canary Islands. It last erupted in 2021. During that eruption, lava poured out of the volcano and flowed all the way to the sea. It destroyed over 3,000 homes, but luckily, thousands of people were safely evacuated, so it wasn't as bad as it could have been. In the past, scientists were worried that a huge eruption could cause the entire western side of the volcano to break off and crash into the ocean. This could create a mega tsunami, sending massive waves hundreds of feet high across the Atlantic Ocean. But more recent studies have shown that this is very unlikely to happen. Mount St. Helens is a volcano in Washington State in the United States. It had a massive eruption in May 1980 that ended the lives of 57 people. That eruption also caused the biggest landslide ever recorded. Hot, pressurized magma exploded from the volcano, shooting ash 15 miles into the sky. Ash covered a huge area, and around 230 square miles of land was destroyed. Mount St. Helens is still active and is expected to erupt again someday, possibly even in our lifetimes. but experts say it's not likely to have another huge sideways blast like the one in 1980, thanks to a deep crater that is now formed at the top. It will change the way the volcano might erupt. Popocatépetl is a big, active volcano in Mexico. It's been slowly erupting on and off since the early 2000s. It's really close to a lot of people, just 40 miles from the Mexico City metropolitan area, which has about 22 million people, and 30 miles from Puebla, which is home to about 6 million inhabitants. If Popocatépetl had a huge eruption, it could cover Mexico City in thick ash as much as 8 inches deep. That ash could block drains, mess up the water, and even stop the electricity from working. Even worse, fast-moving lava and super hot flows, called pyroclastic flows, could rush down the mountain and destroy towns nearby. The volcano was quiet for 50 years, but now it rumbles and shakes pretty often. There have been over a dozen small eruptions, including some as recent as February 2024. Some nearby places got covered in ash, but scientists say this isn't too surprising, and they're keeping a close eye on it.
Now, history teaches us that the supercontinent existed a long time ago, around 300 to 273 million years back. At that time, all the continents on Earth were buddies and hanging out together. They formed an amazing crew called Pangea, or Pangea if you're feeling fancy. The name comes from a Greek word which means all the Earth. Pangea also had a massive water neighbor called Panthalassa. So our entire world was a huge piece of land surrounded by a huge piece of ocean. The megacontinent looked like a giant sea, stretching between the tippy top and bottom of our planet. But as stories go, things change. About 200 million years ago, in the early Jurassic epoch, like dinosaur times, Pangea decided to throw a breakaway party. Forget about the old ideas of continents just drifting around like big icebergs. It split up into smaller chunks, forming the continents we know today. Oh, and it created the Atlantic and Indian Oceans as a bonus. Pangea's tale was first told by a German weather expert named Alfred Wegener in 1912. But how did he learn about something that happened so long ago? Imagine the Earth's core as a big, cozy fireplace, giving off heat. This heat creates special swirling currents in the Earth's outer shell. We can think of it as the Earth's crust, which looks like a big puzzle with many puzzle pieces. The hot currents make these puzzle pieces, called crustal plates, move around. Sometimes they push apart, sometimes they crash into each other, and sometimes they slide past one another. It's like a fantastic dance party that goes on beneath our feet. One day, Wegener looked at the shapes of the continents and thought that, hey, those coastlines of South America and Africa kind of fit together. And they really did. So he imagined that way back, all of the continents hung out together as one big landmass. But he couldn't just go and say that without any proof. So, how do we know Pangea really was a thing? Well, there are some clues that brought us to this amazing discovery. One clue is like when you put a puzzle together and the pieces fit just right. Take a look at the shapes of today's continents. You'll notice that they could fit together almost like a perfect match. Obviously, their shapes changed over time. It happened millions of years ago, and since then, the shores of continents have been washed by waters for years. But even so, we can still see how well they fit together. Another clue comes from checking out fossils. We know that ancient animals left a lot of fossils behind. That's how we learn their history and what species there were. But when scientists compared fossils found on different continents, they found something interesting. These fossils look similar. Surprisingly, they belong to the same groups of animals, even though they were far apart. It's not like these animals could swim across the ocean on their 4 paws. And it's unlikely that this particular type of animal originated in 2 places at the same time. And finally, the mountains. Imagine exploring underwater and finding huge mountains in the oceans. These underwater ranges and deep trenches are like scars from when Earth's tectonic plates moved around. They serve as another proof that the continents are part of something bigger. When you look at these things together, you get a pretty clear picture. The Earth's continents were once huddled together in the supercontinent. They've since gone their separate ways, but the memories of their grand adventure are still written in the shapes of coastlines, the rocks they left behind, and many more. But it's obvious to us now. At the time of Wegener's discovery, there were different ideas flying around. Some folks thought that the continents sank down to make the oceans, but Wegener had a different take. He thought that the continents are always on the move. He even came up with a fancy phrase, continental drift, to explain it. Later, he was joined by another scientist named Alexander du Toit. He added a little twist to the story, suggesting there were two original continents, Laurasia in the north and Gondwana in the south. But the real party didn't start until the 1960s, when scientists figure out the secret ingredient in this recipe, plate tectonics. And finally, this theory explained everything Wegener and du Toit talked about. Wegener's theory was proven correct after 50 years. As time passed, we learned more and more about our planet. We found out that the Earth used to have multiple supercontinents. Before Pangea, there was a megacontinent called Rodinia around 1 billion years ago. And later on, Pannotia joined the scene about 600 million years ago. What's interesting is that the continental drift story is far from over. Our continents are always on the move. Africa is giving Europe a friendly bump, and Australia is playing a game of bumper cars with Southeast Asia. You know what's on the horizon? Another supercontinent. So, how will this next supercontinent come together? Well, there are 4 major possibilities: Novo Pangea, Pangea Ultima, Orica, and Amasia. These might sound like superhero names, but they're actually ways the puzzle pieces could fit. Let's look at them all. First, Novo Pangea. You know how there's the Atlantic Ocean on one side and the Pacific Ocean on the other? Well, if these oceans keep doing what they're doing now, the Atlantic will keep opening up while the Pacific squeezes in. If that happens, the Americas, North and South America, will give each other a big high five. And Antarctica, that icy land way down south, will join the fun too. It'll be drifting northward. Next, Pangea Ultima. In the future, the Atlantic Ocean might get tired of being so wide. It might decide to slow down and shrink a bit. The Americas and the northward drifting Antarctica will probably crash into Africa and Europe. And just like that, a brand new supercontinent forms. There are these spots where the ocean floor is sliding underneath the land. It's like a secret underwater passage. These spots are called subduction zones. So if these secret tunnels will be spreading and spreading all along the east coast of the Americas. The Americas, Europe, and Africa might come together again, and they'd form a supercontinent. This supercontinent would be surrounded by the Pacific Ocean. The next possible supercontinent is Orica. In this scenario, the Pacific and Atlantic Oceans might decide to take a nap and close up. But don't worry, because when one door closes, another opens. In this case, a whole new ocean would pop up to replace them. Imagine a big crack in the ground cutting through Asia, like a zipper opening up. This crack is called the Pan-Asian Rift, and it would become a brand new ocean. With this new ocean comes a new supercontinent, Orica. Australia is currently drifting northwards, like it's trying to find a nice spot at the center of our planet. East Asia and the Americas might join in from both sides. After that, Europe and Africa might link up with the Americas, and boom, Orica. And finally, Amasia. It might form if some of the tectonic plates go north. They can take continents like Africa and Australia along for the ride. They'll be hanging out around the North Pole. All the continents except Antarctica might come together. And even though they might gather around the North Pole, they won't close off the oceans. The Atlantic and Pacific Oceans would still be open for business. How this grand reunion happens depends on the Earth's tectonic movements. So far, we believe that Novo Pangea is the most likely scenario. It also depends on what exactly happened to Pangea after it broke apart. And when the new supercontinent appears, what's going to happen with the weather? How will the ocean behave? And what about the animals and plants? These questions all light up our minds. Who knows? Maybe someday our descendants will look at the world map and see this incredible journey come full circle. So keep asking curious questions and stay tuned for the next 100 million years.
The floor is lava. Haha, just kidding. But honestly, it's kind of falling apart. You might not feel it yet, but a huge part of North America has already lost 37 miles worth of rock from its foundation. And no, this isn't about earthquakes or giant sinkholes. It's about the continent losing pieces of the very thing that keeps the ground from wobbling around like a bad carnival ride. A team of researchers has just dropped a geological bombshell. Part of North America's ground is thinning out like a very sad, very slow ice cream drip. How do they know? They basically gave Earth a high-tech full-body MRI and created 3D maps showing how rocks once considered indestructible are now melting away into the planet's guts, like an upside-down cheese pizza inside an oven. But to really understand this mess, you first have to meet my old friends, cratons. Cratons are like the roots of the continents. They're thick, tough, and ancient. We're talking billions of years old. These bad boys survived meteor impacts, supervolcanoes, and even the tectonic movement of plates. If the plates got into fistfights, for example, you can bet we would see mountain ranges being born. If they got a divorce, drifting apart from each other, then a whole new ocean would be born. All of these things leave scars on the surface of Earth, but the cratons seem to always remain unfazed, like the cockroaches of geology. And since a craton can basically get punched in the face and feel nothing, scientists always assumed these things were nearly indestructible. But then, a group of researchers took their fancy machines to the test and realized that, wait, the cratons are falling apart? How? Enter the Farallon Plate, a really ancient tectonic plate that started to slide under North America's major plate over 100 million years ago. This is a pretty normal process, actually. It's called subduction, and it's how Earth recycles rocks and keeps itself from overheating. This subduction thing has been happening for so long that, by now, the Farallon is almost 400 miles away from the craton, sitting pretty chill at the lower mantle, weirdly close to the outer core of our planet. But the Farallon has been causing trouble, like that one roommate who moved out but keeps leaving weird stuff in the fridge. You see, as it sinks, it tugs on the bottom of North America's foundation, stretching it out and causing pieces to fall off into the deep mantle. And if that wasn't enough drama, the sinking Farallon has also leaked water and carbon dioxide into the surrounding rocks, making the craton even softer and easier to shred apart. Thanks, Farallon. Very cool of you. By studying hundreds of earthquakes across thousands of monitoring stations, scientists have confirmed the story. Big chunks of continental material are dripping downward, thinning the craton by as much as 37 miles. That's more missing rocks than can fit into a milk carton. Sounds dramatic, right? But don't worry. This is happening at a snail's pace. It'll take millions of years for anything noticeable to happen. Your great-great-great-great few grandkids from the distant future might still be standing on solid ground. But don't get too comfy. This thing may not be an urgent problem, but there's another type of sinking that's happening faster than you can say, "Help!" Here's the thing. By 2050, at least 32 major cities in the US, including New York, Baltimore, and Charleston, could be partially underwater. And guess what? This one is mostly our fault. Scientists noticed that since 2007, some cities have been sinking into the ground between 0.04 and 0.08 inches every year. Charleston, in South Carolina, is pulling ahead in the worst way possible, sinking 0.15 inches annually. Sure, these numbers sound tiny and a bit ridiculous, but Charleston is barely 9 feet above sea level, and a little sinking goes a long way when the ocean is breathing down your neck. On really bad flood days, people there have to abandon their cars and basically swim home. This whole phenomenon is called land subsidence, and when you mix sinking land with rising sea levels, you get a disaster cocktail of flooded streets, salty farmland, ghost forests, and a lot of very cranky homeowners. And it doesn't stop with just homes. Infrastructure like bridges, roads, airports, and power plants, all things we rely on daily, are also at risk of serious damage. Flooded electrical grids and sunken highways could cause billions more in economic losses and create major safety hazards for communities. Now, let's be fair. Not everything is humanity's fault. Some of this trouble dates all the way back to the Ice Age. About 12,000 years ago, massive ice sheets covered the northern US. They were heavy, like seriously heavy. The weight pushed the land down, and when the ice melted, the ground didn't just pop back up like a trampoline. Instead, it started playing a weird game of geological seesaw. The places that were squished started rising, and the places that weren't got pulled down. This whole process, called glacial isostatic adjustment, try to say that 3 times fast. But of course, humans found a way to make it worse. Groundwater extraction is a major culprit. Think of it like pulling the stuff out of the mattress. After a while, the whole thing just sags. In places like California's Central Valley, the land is dropping by up to 8 inches a year because we keep pumping out water during droughts. In cities like New York, the problem isn't just water. Skyscrapers themselves are making it worse. Yep, turns out if you stack millions of tons of concrete and steel onto soft ground, it tends to flatten. And in case you're wondering, the total mass of New York City's buildings is around 1.68 trillion pounds. That's about the same as 3.5 million statues of liberty piled up. With so much weight concentrated over a relatively small area, the underlying soils have no choice but to compress over time. And if you thought it couldn't get messier, think again. We've been building dams, which stop rivers from delivering fresh sediment to coastal areas. That sediment is kind of like Mother Nature's way of fluffing the ground back up. Without it, coastal lands are compacting like an old sponge. Plus, when wetlands are drained for agriculture or construction, the peaty soil dries out and collapses. Honestly, it's like the ground just can't catch a break. Scientists also noticed that the areas that used to be lush wetlands are now among the fastest sinking spots in the country, especially along the Gulf Coast. Louisiana, for example, is losing about a football field of land because of this mix of subsidence and rising seas. So what's the endgame here for us regular people who just want to live above sea level? Well, it's not looking great. Ghost forests, which are basically drowned woodlands, are popping up. Farmland is turning salty and unusable. And even sunny day flooding, where streets flood without any rain, is becoming a thing. Yikes! Meanwhile, over on the West Coast, California is not exactly winning either. San Francisco and Los Angeles are both sinking, which means that rising sea levels could hit them twice as hard and twice as fast. In some places, like the Palos Verdes Peninsula, the ground has been sinking so fast, people over there might as well live like moles. So, is America turning into the next Atlantis? Probably not next week, but without serious action, like cutting back on groundwater pumping and planning smarter cities, at least 500,000 people are in serious danger. And the housing damage could easily rack up a jaw-dropping $109 billion by 2050. In the end, while North America isn't about to sink like a poorly made souffle, it's definitely showing some cracks in the crust. So maybe let's ease up on groundwater pumping, rethink how and where we build, and invest a little more in keeping our feet dry. After all, if the floor really does become lava someday, we're gonna wish we had at least fixed the leaks first. See how the Antarctic Peninsula looks just like South America, but upside down? This isn't just a coincidence. It's the ghost of a 30-million-year-old breakup. These continents were once connected, But their divorce gave birth to an ocean current so powerful, it was capable of completely freezing Antarctica and shaping its landscape. Here's how it went down. Tectonic plates pulled a sneaky move and cracked open a ridiculously narrow passage in the ocean, about only 500 miles wide, forcing 4.5 trillion cubic feet of water to flow inside this geological straw. This was the birth of an ocean current stronger than the Amazon River. This ocean current, called the Antarctic Circumpolar Current, by the way, flows in a circular motion, going clockwise because of the strong winds that blow over there. This circular motion around Antarctica caused erosion, shaping the landmass of the continent into a circle, except for that stubborn peninsula, which is being slowly dragged east like a kid refusing to leave a playground. Wait, South America and Antarctica used to be one? Yep, a long time ago. South America, Australia, and Antarctica were all part of a supercontinent called Gondwana, which also included Africa at some point. Back then, South America and Antarctica used to be basically joined at the hip by a land bridge called the Antarctic Land Bridge, which just so happened to be a lush green forest and also a great dinosaur highway. Yeah, you heard it right. Dinosaurs. A 95-million-year-old dino, whose name I can't pronounce, sorry, was discovered in Australia, and scientists found out it had actually been a distant cousin of Argentina's Sarmientosaurus. Same jaw, same chisel teeth, same everything. These guys were like identical twins, separated by an ocean. How? Because back then, Antarctica wasn't a frozen wasteland. It was a temperate rainforest, like Oregon, making it a pretty nice travel route for a dino family. But the land bridge wasn't just for dinosaurs. About 40 million years ago, the ancestors of Australia's marsupials waddled to the land down under all the way from South America, taking the Antarctica route, another proof that these continents used to be connected. Things remained somewhat peaceful for the dinos and the marsupials until Earth's ground started moving. This is what a German scientist called the Continental drift theory, back in 1912. Our German friend here basically looked at the coast of South America and went, "Hey, this looks like it could fit into the coast of Africa." Like a scientific Sherlock Holmes, he noticed what others had overlooked for centuries. The continents were clearly pieces of a larger puzzle. And he was right. Here's the deal. Planet Earth is made of many layers of rocks and metals, like a cosmic onion. The outermost layer, the lithosphere, is divided into pretty solid tectonic plates that move atop a layer of softer, somewhat molten rocks, like slippery ice. This is why the plates move. In fact, they've been rearranging Earth's face for billions of years, with supercontinents forming and breaking apart in cycles, like a slow-motion game of bumper cars. This movement might be pretty slow since most tectonic plates only move 0 to 3.9 inches every year, except for the Nazca plate, racing ahead at 7.8 inches, about as fast as your hair grows. But don't let their snail's pace fool you. These shifting slabs are the ultimate planet shapers. Their slow dance gives us everything from earthquakes that build mountains like the Himalayas, to rifts that birth oceans like the Atlantic. All because the oceanic crust is dense and sinks like a stone, while continental crust floats like a cork. It's this density difference that explains why continents exist at all. Without it, Earth would be completely covered by shallow seas. This slow-motion planetary renovation project is exactly what tore South America and Antarctica apart 30 million years ago. The plates under these continents started to drift apart in a process called crustal extension. It's like the lithosphere was pizza dough being slowly stretched until it thins and splits. As the crust stretched, it became thinner and weaker, eventually cracking like the surface of a drying lake bed. This whole thing gave birth to a new tectonic plate, the Scotia Plate, that emerged between South America and Antarctica, like a geological divorce lawyer. For a while, parts of this plate stayed above water as the last gasp of the Antarctic land bridge. It was Earth's version of that one thread still connecting your hoodie after the zipper breaks. These final connections might have persisted as chains of islands, but just like that fraying hoodie, the connection couldn't last forever. Eventually, this small but mighty plate became the final nail in the coffin of the land bridge connecting the two continents. Just like all the tectonic plates, this one was also on the move. As it expanded eastward, it opened a new passage of water called the Drake Passage, slowly covering the Antarctic land bridge with ocean water. The process was like pulling open elevator doors. At first, just a crack, then wider and wider until the connection was completely broken. This geographical divorce had chilling consequences. The new Drake Passage allowed the Antarctic circumpolar current to form, creating an endless loop of cold water that isolated Antarctica, shaped its land, and even cooled the entire planet. This current acts like a wall around Antarctica, blocking warm water and invasive species while regulating global climate. Eventually, Antarctica turned into an icebox that is 98% covered in ice sheets, and that holds about 61% of Earth's fresh water. Nowadays, this continent holds the title of the windiest, driest, and iciest place on Earth. It's a frozen desert where temperatures plunge below -128.6 degrees Fahrenheit, cold enough to freeze your breath mid-air. A layer of ice there can be more than a mile thick, and it expands even further in winter to cover an area larger than the continental United States. Today, if you want to travel to Antarctica, the quickest sea route is through the Drake Passage, a 500-mile-wide body of water that is narrow enough for the winds to scream across thousands of miles, transforming into monstrous waves that can tower up to 49 feet. Though calm days create waves only 13 to 16 feet high. Still twice as tall as Atlantic waves, mind you. This is probably why sailors call this stretch of ocean the Drake Shake. But tectonic movement isn't just about shifting continents. It's Earth's ultimate life support system. You see, about half of our planet's heat comes from radioactive decay in the core. Thanks, uranium-235. Something like nature's nuclear reactor. This heat is behind everything from volcanoes to the very plate motion that once connected Antarctica to South America. And it only comes out of the core because of tectonic movement. Without this internal heat engine, Earth would be just like Mars. When the plates move and release heat, they also release CO2 gases into the atmosphere, regulating the temperature of our planet. And when the plates move underwater, they take a lot of this CO2 back to Earth's interior, recycling all this gas. This is why the plates can change our air, climate, and even the evolution of life itself just by moving around. But billions of years ago, these plates were not moving around. Back then, it was like Earth was wearing a solid ceramic shell with many cracks. But even without tectonic movement, the heat managed to escape through these cracks in a process called stagnant lid tectonics, kickstarting all life on Earth. And no, tectonic movement is not a thing of the past. Earthquakes are the living proof that it is not just happening today, but might repeat again on a more dramatic scale in the future. You see, to form supercontinents like Pangea, smaller megacontinents have to dive beneath another. And scientists predict that a similar process might create a new supercontinent called Pangea Proxima in 250 million years. By then, humans might be extinct or living on Mars, but Earth's tectonic dance will continue, even without us. Not bad for something that moves more slowly than a traffic jam. Turns out, Antarctica and South America used to be BFFs before all that tectonic drama split them up, like a messy breakup that literally froze one of them out. Now, they just awkwardly mirror each other from across the Drake Passage. Classic exes.
Consider South America and Africa. Don't they kind of look like they fit together, like puzzle pieces? Well, they actually did. But about 130 million years ago, South America was like, bye, and slowly started drifting away. These days, it's around 1,800 miles from Africa, and it's still on the move. Every year, the continent shifts a little more toward the Pacific Ocean. So, how's that even happening? Tectonic plates are constantly moving. That's what makes the Earth's surface shift over time, going from this to what we see today. But those movements happen so slowly that you and I can't see them go. So, no, Brazilians or Chileans aren't out there feeling their continent inching westward. But the numbers don't lie. South America is moving, and apparently all it wants is to get as far away as possible from this massive underwater mountain range called the Mid-Atlantic Ridge. But what exactly is pushing the land toward the Pacific Ocean? It is the heat inside our planet. Way down beneath the ocean, there are cracks in the Earth's crust, and magma, super hot melted rock, rises up through those cracks. When that happens, the magma cools and hardens into solid rock. Over time, this process might build underwater mountains, like the Mid-Atlantic Ridge. And as more new crust forms, it begins to push the older crust out of the way. In the process, tectonic plates and the continents riding on top of them get pushed along. Now, on the other side of South America, over by the Pacific, there is the Nazca Plate. It's heavier and it's moving eastward. Since it is denser, it is sliding underneath the South American plate. This entire process is called subduction, and it's happening at a rate of about 3 inches per year. By the way, the collision between these two plates is what's behind all those breathtaking volcanoes scattered throughout the Andes, and it's also making the continent move. So, if everything goes according to plan, projections show that South America will end up more centered in the Pacific Ocean in the future. But some models suggest something way crazier. Before we get into that, though, we need to clear something up. Why on earth isn't Africa following in South America's footsteps? I mean, shouldn't it be drifting west too? Well, not quite. Africa is doing its own thing, because it sits on the African plate. So the Mid-Atlantic Ridge is located between those two continents, and just like it pushes the South American plate, it also pushes the African plate, but in the opposite direction. It's like this ridge is trying to split up two ex-besties, you know? But there's more. Africa is also being influenced by the East African Rift. That's one of those massive cracks we talked about earlier, but it's happening on land, which makes it extra dramatic. This is what's causing the continent to slowly split apart. It's a long story, but let's just say the rift is pulling Africa in more directions than South America ever had to deal with. Okay, now it is finally time to talk about that crazier thing that might happen to South America and everything around it in the future. Theory number 1. It could break away from North America. I know, super dramatic, but don't panic. We're talking hundreds of millions of years from now, and I won't be around. You see, both continents are moving in the same general direction, but at different speeds. The North American plate is cruising along at about 1 inch per year, while South America is moving a bit faster. So even though they're heading the same way, they are not keeping pace. Over time, as the Atlantic Ocean continues to widen and the Pacific keeps shrinking, all this tectonic movement could eventually pull the Americas apart. Theory number 2. Marine life could go through some major changes. Right now, the Americas act as kind of a giant wall between the Atlantic and Pacific Oceans. Because of that, sea animals have evolved differently on each side. Take the green sea turtle, for example. The ones living in the Atlantic tend to be bigger and lighter in color. Meanwhile, their Pacific cousins are usually smaller and darker. But if, one day, there is no land blocking these two populations from mixing, they would end up with brand new migration routes, new nesting spots, and a lot more overlap in their territories. Now, multiply that scenario by hundreds of other species, and things could really get shaken up. We're talking about new interactions, unexpected competition, and maybe even the rise of entirely new species. Alright, theory number 3. America might meet Africa again. Right now, the Mid-Atlantic Ridge is busy creating a new seafloor, and because of that, the Atlantic Ocean is slowly getting wider. But in about 125 million years, scientists believe that process could come to a stop. Instead of the seafloor spreading apart, the ocean floor might start getting pulled under the continents. When that happens, the Atlantic will stop growing and start shrinking. And the water section between South America and Africa is likely to be the first part pulled beneath the land. That means the Americas and Africa could meet again. And when that happens, border countries could turn into super shaky places, with earthquakes happening all the time and brand new volcanoes popping up left and right. The eastern United States would no longer be known for the peaceful green slopes of the Appalachians, but for snow-covered giants that occasionally spew lava and ash, more like the Cascade Range out west. Countries would end up with totally new neighbors. Brazil might line up with Nigeria and Cameroon. Uruguay could be sitting right next to Angola. And Argentina might be sharing a border with South Africa. So if these two continents really do merge, how intense would that be? Well, for starters, this new supercontinent would instantly become the biggest one on Earth, about 1.5 times the size of Asia. And chances are, a brand new mountain range would form right where the continents meet, creating a natural border between nations. Being part of the same massive continent could make a lot of things way easier. For one, tourism could totally take off. People traveling between countries by land without needing pricey plane tickets could be a game changer. But it wouldn't stop there. Other types of economic activity could get a major boost too. Now on one side we have South America, which already produces and sells a wide variety of foods, from wheat to bananas, beef, cocoa, soybeans, hey, you name it. On the other side, there is Africa, exporting things like textiles and clothing. That alone would make them a super powerful bloc when it comes to trading raw goods. But can you name another important thing these two continents have in common? Yep, petroleum. Countries in South America, like Brazil, Venezuela, and Colombia, are major oil exporters. And over in Africa, you've got Nigeria, Algeria, and Libya doing the same. Now, can you see just how powerful that kind of union could be? Meanwhile, let's talk about animals. These two massive lands coming together could lead us to wild meetups, like a capybara sharing space with a Nile crocodile, or a sloth seeing a hyena from the top of a tree. This could even lead to new animal hybrids showing up, like a tabby crocodile or a sloth hyena. Okay, those weren't the cleverest names, and honestly, these animals wouldn't be able to mate or even wouldn't want to. But you get the point, right? It's not all positive, unfortunately. New species showing up could become predators, competitors, or even parasites to the native plants and animals. It would take a long time for things to settle into a new balance in those border regions. But honestly, no one really knows how long it would take. The only thing I do know is neither of us will be around to see it, which is okay.
There's a mysterious dent in our planet's magnetic field, and it's slowly growing. It stretches from South America to Africa, and what's horrifying is that it's weakening Earth's protection shield against the sun. They call it the South Atlantic anomaly. And while most people on Earth don't feel its effects for now, satellites and spacecraft passing through it already do. Deep inside our planet, there's a giant ball of molten iron and nickel, the outer core. The metal inside is so hot that it's constantly moving and swirling. This movement creates electrical currents, and when electricity flows, it generates a magnetic field. This field surrounds the entire planet like a protective bubble. Without it, life on Earth would be in serious trouble. The sun blasts out charged particles called solar winds that could destroy our atmosphere over time. Luckily, the magnetic field deflects most of these particles, keeping us safe. Other planets without magnetic fields like Mars lost their magnetic fields, got their atmospheres stripped away, leaving them dry and lifeless. And also, without the magnetic field, our technology and equipment gets all messed up. Satellites, power grids, and even airplanes could get hit by intense radiation. This would lead to communication failures, GPS errors, and blackouts. And now, something strange has been going on underneath the African continent. An enormous blob of dense rock deep inside the Earth, called the African Large Low Shear Velocity Province, has been growing and messing the magnetic field up. Scientists think that this weird rock-like thing is messing with the flow of the outer core, disturbing the magnetic field above it. That disturbance is what weakens the shield over the South Atlantic. It's like a crack in a windshield. It might not shatter immediately, but the weak spot spreads over time. Now, NASA is watching it closely. Satellites passing through this anomaly experience random glitches and shutdowns. Sometimes their circuits short-circuit from high-energy solar particles. Mission operators have to turn off systems before entering the danger zone, and it's only getting worse. The anomaly is drifting westward. This means that new areas could fall under its influence. What's even worse, it seems like it's been splitting in two, which means our planet has been developing two weak spots instead of one. And here's something crazy. Some scientists believe that this entire thing is part of a long-term cycle that's been repeating for over 11 million years. And that cycle would make our magnetic poles flip. North could literally become south, and vice versa. Earth's magnetic poles have flipped before, although the last time that happened was 780,000 years ago, way before humans started roaming around the planet. These reversals happen every few 100,000 years. Now, some wonder if our anomaly is the beginning of the next flip, but scientists aren't sure if we're overdue or just in a temporary phase. Luckily, if a flip were to happen, it wouldn't be instant. It would take thousands of years. But as the field weakens, more radiation would reach Earth's surface. It would mess up not just technology and equipment, but also us, and even animal migration patterns. Many animal species use Earth's magnetic field to navigate. And they even have some potential culprits that could have caused this weird thing. There are two massive, mysterious blobs of hot, dense material deep inside our planet. One is under Africa, and the other formed under the Pacific Ocean. They're called large, low-velocity provinces. Basically, huge underground rock-like formations. Both blobs are gigantic. Each one is hundreds of times taller than Mount Everest and stretches across thousands of miles. They make up 6% of the entire Earth's volume and are one of the biggest geological features inside our planet. They're also super weird and could be structured more like trees than some lumpy mountains. Scientists imagined them as softened rock at first, but based on recent imaging techniques, it looks like they might actually have jagged, branch-like structures extending upward. These are like branches of a tree. They could be feeding hotspot volcanoes at the surface, like the ones in Hawaii. Scientists still don't know exactly what these blobs are. However, they believe they control a lot of what happens on Earth's surface. Stuff like volcanic eruptions, earthquakes, and, of course, changes in the magnetic field. They may also be linked to supervolcanoes and mass extinctions. The eruptions that they could cause could be like the ones that happened in ancient times and possibly wiped out entire species. If the blobs are connected to supervolcanoes, they might have had absolutely insane disasters in the past and might even cause more troubles in the future. But they also help us control plate tectonics, which affect earthquakes and mountain formation. They might also contain material from Earth's early days, or even from Theia. That was the mysterious planet that crashed into Earth and helped form the Moon about 4.5 billion years ago. Finally, Earth literally breathes because of these blobs, which is insane. The Sun and the Moon's gravitational pull stretches the Earth slightly, making it rise and fall like a breath. But now, scientists found that this tidal movement is slightly off-kilter over the blobs. They literally interfere with how the Earth's mantle moves. These two huge structures actually actively affect how our planet behaves, which is super dangerous. We only recently learned how these blobs actually appeared on our Earth. It's all because of the sunken ocean crust. Over hundreds of millions of years, parts of the ocean floor have sunk deep into the Earth's mantle. These slabs of rock stacked up at the bottom. This way, they slowly formed these massive blobs of recycled crust. Scientists haven't agreed on whether the blobs are heavier or lighter than the rest of the mantle. One study suggested they are denser, which would mean they're made of heavier material. Another study suggested they are less dense, meaning they could be hot, rising plumes of lighter rock. The African blob is suspected to be one of the causes of the South Atlantic anomaly, but scientists are still investigating how exactly they are connected. Since the African blob is basically a giant dense blob sitting on top of the outer core, it could cause troubles. The African blob is hotter and possibly chemically different from the surrounding mantle. It could be disturbing the outer core, affecting the magnetic field, weakening it. Another crazy thing is that they might contain an ocean of water locked inside their minerals. Scientists discovered that huge amounts of water, as much as all of Earth's oceans combined, are trapped in minerals deep in the mantle. One mineral, ringwoodite, can store water inside its crystal structure, but it's only possible under extreme pressure and super hot temperatures, like in the deep mantle. So there could be vast hidden water reservoirs inside the blobs. Not literal bodies of water, of course, but tons of little water molecules weirdly locked away deep beneath the surface. If this water were somehow released, it could potentially trigger massive volcanic activity, or even affect global climate. But the blobs are not the only factor for this weird anomaly. Other factors also contribute, like the tilt of Earth's magnetic field, changes in the core's iron flow, and even plate tectonics. However, the large provinces are making things worse. They keep evolving somehow. Scientists think that it might be because massive columns of hot rock called mantle plumes are rising from deep inside the Earth. These plumes could be pushing the giant pieces of Earth's crust like tectonic plates around, especially in the Pacific Ocean. If this is true, then these giant underground blobs aren't just sitting still. They're moving, changing, and shaping the Earth's surface all the time, almost like they're alive. So what does this mean for the future? If the African blob continues evolving, the South Atlantic anomaly might get larger or shift further, affecting more satellites and spacecraft. Right now, there are still more questions than answers. Every new data point helps predict how it will evolve and whether we need to worry about the worst-case scenarios. For now, NASA isn't panicking, but they're watching very closely. Because whether it's a harmless shift or a sign of something bigger, one thing is clear: something deep inside Earth is changing. A giant crack, more than 2,000 miles long, is splitting open across Africa. Roads, houses, even schools are getting torn apart. Now, scientists think they've finally figured out what's causing it: an enormous column of scorching hot rock called superplume, rising from deep inside the Earth. And it's slowly pushing the land apart inch by inch. This isn't a small shift though. The continent is breaking in two, and the clue to what's going on could be hidden thousands of miles away in Hawaii. And why does the United States suddenly have a role in all of this? Hang on, we'll get there. First, it's important to know this isn't new information. Africa has been slowly splitting for about 25 million years. This is happening in a region called the East African Rift System. It stretches thousands of miles from Ethiopia down to Mozambique and is the largest active continental rift system on the planet. And by that, I mean places where the Earth's crust is being stretched and pulled apart, causing faults, earthquakes, and volcanic eruptions. Scary stuff to say the least. Back in 2018, for example, a massive crack appeared near a small town just west of Kenya's capital, Nairobi. In some spots, it was about 65 feet wide. That's almost the length of two school buses parked one after the other. The whole thing was terrifying. It happened fast and left a trail of destruction. Roads were cut off, farms torn apart. People were on edge as the ground opened up beneath their feet. And I mean that quite literally. One man watched the crack rip straight through his home. He barely had time to grab a few of his belongings before his entire house collapsed. Sounds terrifying, right? Since it happened in the East African Rift region, panic spread fast. The media was all over it, claiming it was proof that Africa is splitting apart. People standing near the crack thought, "Oh boy, it's already happening." And many still believe that today. But that's not actually the case. At least not with that particular crack. Because after the initial panic, videos and photos of it revealed clues that it wasn't related to tectonic plate movement. First clue: the two sides of the crack didn't match. Like trying to fit the wrong puzzle pieces together. They simply didn't line up. Second clue: the gap wasn't one continuous line. There was some kind of soiled bridges in between. All this showed it was sudden erosion. I mean, some specialists believe the crack had once been filled with volcanic ash from nearby Mount Longonot. But then the region was hit with heavy rains. When water soaked through the soil, it washed the ash away, leaving the gap exposed. Problem solved. Even after the truth came out, it was too late. This event brought the whole "Africa is splitting" talk back. And here's the thing: even though that crack had nothing to do with it, make no mistake, Africa is breaking apart. That's because the continent sits between two tectonic plates, the Somali plate in the east and the Nubian plate in the west. The problem is they're moving away from each other, and as they drift apart, the gap in the East African Rift keeps getting wider. Eventually, the Somali plate could split completely from the Nubian plate, creating an entirely new landmass, something on the scale of Madagascar or even New Zealand. You don't have to worry though. This process is super slow. So slow that none of us will see it finished. Experts say the continent is moving apart by about 0.3 inches a year in some places. To give you an idea, that's less than the length of your fingernail. So we can say this split will take millions of years, which is good news for the people living there. But that doesn't mean they won't feel the effects of this slow break. In fact, they're already happening. Take Ethiopia's Afar region, for example. Back in 2005, this area showed just how unpredictable the rift can be. In a short period, 420 earthquakes hit the area, opening up a massive fissure. What usually takes centuries happened in just a few days, completely challenging what scientists thought they knew about the speed of geological changes. Back then, the crack stretched for more than 35 miles, and life around it is still far from easy. Recent earthquakes destroyed much of the local infrastructure. 37 schools were damaged, leaving 5,000 students without classrooms. And that was just one part of the damage. As the tectonic plates keep moving apart, water will eventually flood into this region, creating a brand new ocean, according to some predictions. Countries like Zambia and Uganda, which are landlocked today, could one day have a coastline. That could be great news for them, as it might open up new trade routes and completely reshape their economies. Don't get too excited though. We won't be diving into the waters of this sixth ocean anytime soon. The splitting process will take another 5 to 10 million years. But it's tough to say exactly when, since big seismic events, like earthquakes, could make it all happen faster. So here's what we know. The Somali plate and the Nubian plate are in the middle of a dramatic tectonic breakup, slowly moving apart. Africa is breaking in two. Earth will probably gain a new ocean because of it. But until recently, we didn't know exactly what was triggering all of this. Like, yeah, those tectonic plates are moving, but why? I mean, is this massive geological process being driven by something happening in Earth's mantle? Or could it have a much larger, deeper source? Well, scientists think they may have finally cracked the mystery. They believe the continent is breaking apart because there's a deep mantle superplume, a huge column of hot rock beneath the East African Rift system. Think of it as a massive subterranean hammer pushing upward, pressing against the crust, and slowly cracking it apart. But here's the interesting thing. Scientists reached that conclusion thanks to something that happened in a completely different part of the world, Hawaii. Under this US state, there's also a plume of super hot rock rising from deep inside the planet. It melts the crust above it, and that's what fuels Hawaii's volcanoes. As the Pacific Plate drifts over this plume, molten rock breaks through in new spots, creating volcano after volcano. Over millions of years, that's how the Hawaiian Islands were formed. This Hawaiian plume contains noble gases like helium and neon. And you know where else scientists found those same gases? That's right, beneath the East African Rift System. Bingo! That discovery backed up the theory that a superplume is driving what's happening in Africa. And we call it super because it might be massive. You see, these same gases have been found in volcanic rocks from Kenya all the way down to Malawi. So everything points to the existence of a single superplume that stretches from the Indian Ocean to the Red Sea, not a bunch of several isolated sources. If their data and research are correct, scientists estimate that this superplume beneath Africa likely starts at the core mantle boundary, which is located about 1,800 miles deep inside the Earth. While the East African Rift System's chemical signatures are similar to those found in volcanic rocks in Hawaii, they're not identical. The Hawaiian plume is thought to be a narrow, rising stream of hot mantle, a bit like the movement inside a lava lamp. Africa's plume might be shaped differently, more like a large mass of hot, buoyant material rising from deep within the Earth. As it reaches the surface, this hot material hits the colder, solid outer layer and spreads out, pushing hard enough to crack it open and trigger intense volcanic activity across the region. And if this theory is right, we're watching a slow but unstoppable force that will redraw Africa's map and change the continent forever.
Some mistakes have the power to change the course of history. One such story has to do with an old, boring key that could have saved the Titanic from its infamous demise. The key belonged to the crow's nest locker that housed binoculars, which could have helped the lookouts spot the iceberg sooner. There's more. The key wasn't even on board the ship when it set sail. The second officer took it with him when he was taken off the ship at the last minute. As the story goes, the officer forgot to hand the key over to his replacement in his hurry to disembark. So, when the lookouts were in desperate need of binoculars, they were out of luck. One of the lookouts, named Fred Fleet, even testified that if they had had binoculars, they would have spotted the iceberg in time to avoid it. And when asked how much sooner, Fleet replied, "Enough to get out of the way." In 2015, some auctioneers got their hands on Blair's key and presented it as one of the most important artifacts from the Titanic. They truly believed it could have saved the ship. Blair kept the key as a souvenir and passed it down to his daughter, Nancy. At one point, it was up for auction with a price tag of over $80,000. Blair himself was quite the hero, it seems. A year after the Titanic disaster, he was awarded a gallantry medal for saving a crewman who had fallen overboard while he had been on board the liner Majestic. He may have forgotten a key, but he sure didn't forget to be a hero when it counted. This next story is both funny and tragic. It's about NASA's lost $125 million Mars Climate Orbiter. The spacecraft engineers failed to convert from English to metric measurements before the craft was launched, and as a result, they lost it. The navigation team at the Jet Propulsion Laboratory used the metric system of millimeters and meters, while Lockheed Martin Astronautics in Denver used the English system of inches, feet, and pounds. JPL engineers mistook acceleration readings measured in English units of pound-seconds for a metric measure of force called Newton-seconds. What's worse is that none of JPL's quality control procedures caught the error in the 9 months it took the spacecraft to make its 461 million-mile flight to Mars. That's a long time to be lost in translation, don't you think? The miscalculations were enough to throw the spacecraft so far off track that it flew too deeply into the Martian atmosphere and was destroyed when it entered its initial orbit around Mars. It's embarrassing to lose a spacecraft to such a simple math error. And it's hard to think of another example of such a large loss due to English versus metric confusion. Ever heard about the mathematical mistake that led to the discovery of the New World? Spoiler alert, it involves a guy named Christopher Columbus and a really big globe. Back in 1492, Columbus set sail from Spain with a mission to find a new trade route to Asia. He was convinced that he was less than 3,000 miles away from Japan, and just a bit more sailing would get him to the Indies with all their tasty spices. The only problem was that Columbus was a bit off in his calculations, like way off. He made a mistake in estimating the size of the globe, which led him to believe that Earth was far smaller than it actually is. Now I know what you're thinking. Wasn't Columbus afraid that he would fall off the edge of the world? Contrary to popular myth, Columbus and his crew knew the Earth was a globe, just like the ancient Greeks did 2 millennia earlier. They weren't worried about falling off the edge, but rather about the size of the ocean they planned on crossing. And to make matters worse, Columbus had no idea that an unknown landmass existed between Spain and Asia. After weeks at sea, Columbus finally reached the Caribbean. He believed that he had landed on the outskirts of Asia, and so named the islands the West Indies. He went on to explore the Caribbean and the northern coast of South America. But here's where things get really interesting. Even though Columbus insisted until his last day that he had reached Asia, another Italian explorer named Amerigo Vespucci mapped the eastern shore of South America down to Brazil and proved conclusively that Columbus had actually discovered a whole new world. A German mapmaker saw Amerigo's maps and labeled the new landmass America after him. And since his maps were super popular at the time, the name stuck. One man named Alexander Fleming stumbled upon one of the most significant medical discoveries of all time by accident. At one point in his career, Fleming observed the demise of many people from uncontrollable infections. Antiseptics were used to fight this, but they often did more harm than good. In 1922, while he had a cold himself, Fleming transferred some of his, nasal discharge to a petri dish and left it on his cluttered desk. When he finally examined it weeks later, he found that an enzyme had some antimicrobial properties. It wasn't until 1928, when Fleming left an uncovered petri dish next to an open window, that he stumbled upon the discovery that would change the world. The dish became contaminated with fungus spores. And when he examined them under the microscope, Fleming discovered that the bacteria near the fungus were dying. He managed to isolate the fungus and found that it was effective against numerous things that cause diseases. And thus, penicillin was discovered. As Fleming himself put it, "I did not discover penicillin. Nature did that. I only discovered it by accident." Talk about a lucky break. In the early 1520s, the east coast of the United States of America was a big mystery waiting to be solved. The Spanish found Florida, and the English and Portuguese found Newfoundland, but the area in between was like a blank spot on the map. France decided to take action and sent an expedition to explore the area. They chose a guy called Giovanni da Verrazzano to lead the trip. For this expedition, he got 4 ships. Unfortunately, 2 of them were shipwrecked, and a third one went home after doing some other business on the Spanish coast. Only the flagship, La Dauphine, crossed the Atlantic with Verrazzano and his 50-man crew. Verrazzano set sail from Madeira and landed at Cape Fear. From there, he sailed south, but got a little scared of running into the Spanish, so he returned somewhere north of Charleston. He anchored not far from his original landing spot, but unlike other explorers, he preferred to anchor well out at sea. He did send a boat to the shore, and he met the natives. They were described as wearing just some animal skins covering their bodies and garlands of bird feathers. As Verrazano sailed along the coast, he reached the outer banks of North Carolina. He thought that the waters he discovered were those of the Pacific. In reality, what he'd stumbled upon was the Pamlico Sound. He thought that North America was just a long, extremely narrow strip of land. This mistake led mapmakers to show North America as almost completely divided in two. Moving on, Verrazano reached a beautiful place that he called Arcadia, probably Kitty Hawk, North Carolina. Sailing further north, he missed the entrances to Chesapeake and Delaware Bays because he kept quite far from the coast until New Jersey. Then, the moment we've all been waiting for, Verrazano discovered New York Harbor, and he anchored in the Narrows. Later, it was named after him, and now it is spanned by the Verrazano Narrows Bridge. Once Verrazano's sea appeared on the map, it became widely accepted and impacted loads of future explorers. For example, Henry Hudson went looking for a passage to the Pacific in the middle latitudes of the continent. But, as it turns out, the Englishman never did find the Pacific Ocean anywhere near Virginia. And the cartographic myth eventually faded away. It's funny to think about how a mistaken belief could have such an impact on history.